All right, welcome everybody to the second ACM workshop of the semester. Mr. Aaron Herr is going to be giving a advanced workshop on Python, follow up on Betancourt's a couple weeks ago. And Aaron is currently in CSI 41 and has been doing a lot of cool stuff in Python. So pay attention, learn a lot of stuff. If you've never programmed before, I don't know, just roll with it. He's going over more advanced topics today. It might pique your interest or pique your curiosity into learning about programming. And for those advanced programmers out there, it'll show you some of the cool stuff you can do with Python. So hopefully it'll light a fire of inspiration and motivation. So Aaron, without further ado, take it away. I'm probably going to dip out to get my daughter at some point. So don't. If you're trying to talk to me, I may or may not be here. Okay. So Aaron,
Okay.
take it away.
Okay, sounds good. All right, everyone. Like Ernie said, this is going to be a TED Talk by me. So the first thing hold on, let me do this. So the first thing I'm going to go over, because since Alexander didn't have enough time to go over lists, tuples, and dictionaries, I'm going to go over that. And so for those of you in currently CSS 41, you guys will probably understand lists or understand the references to lists a lot better since you guys are going over linked lists in this in CSS 41. So this is so if you so for those of you who are also having troubles, this might clear things up as well. And so yeah, so for lists in Python, it's just basically an array of strings or data types, and so the image on the right side is going to be showing an example of how do you declare a list in Python and how you print it out. It simply is just brackets, and then you just basically add whatever how many types you want into that array. And so for accessing, appending, and removing a list in Python, it is actually really simple. So we go into my if we go into my if we go into one of my demos over here, I will show you guys what it's like here. Let me just pull them up real quick. All right, so for example, this is going to be what it looks like as to showing what a list. So for right now, we're only going to focus on these parts here. So for example, to add from a list, all you really have to do is really just call the list. So for example, we have a list in Python called my list, and how you actually just add stuff. You just simply just go call the list, call the variable my list, and then just call append with the dot operator. And for example, we're gonna call this cans, I guess. I couldn't really think of anything, but we're gonna go with cans because that I can't really think of anything. Car made me think of cans, so we're just gonna roll with that. And so, for example, this is pretty much how you add stuff into a list because it already has a function called append built into the Python standard library. And so if we run this, we're going to get cans printed along with this big array. So you notice how like I added car and I added cans, but it adds it into here. That's pretty much all what append does. It adds it to basically into the array or list if you want to get being technical. So that's pretty much what lists are. And if we want to do the same thing going accessing by index as well, it's the same. All you really have to do is all you really need to do is just choose a number. So if we have like a list, let's say 1, 2, 3. Let's say it's called my list. You just specify it using the bracket and the number, and that's going to tell you which number it's going to be. And when you do append, it's going to increase it by 1. And so, for example, if I do since we added car in, we do something like my list, and then we're going to grab car. So this is what it's doing. It's just printing out cans. My bad, cans. So if we go over here, it's going to print out cans through here. And so with removing stuff from the array, it's actually, I think it's pretty much the same thing. Where if you do something like I don't know, like we're gonna do like list dot remove. Let's do apple. I think this might work. Yep, there you go. So in this case, you notice how when I do remove, all I really have to do in Python, because Python makes it easier, is I just have to call the dot remove function, and it goes to and it basically how this works, is it's kind of like doing popping front. So it's going to another simpler way of saying is that it's going to delete stuff in the beginning of the list. And so in this case, it's giving me this index out of a range error. It's because I probably did something wrong, and so we go back. So we do something like this. Let me just comment that out. I think I already have the code right now. I think I'm just tripping. It's somewhere down here. That I probably removed it, but that's how removing kind of works in that is how removing works in lists. And so for changing items, where it's going to be yet again pretty simple than how you do it in, like, let's say C++, because, well, I think about the same. I guess it really just depends on how you look at it. So, like, for example, if we do like let's say we want to change index 4 to like cantaloupe or something. I don't know. I'm not gonna write that because I don't want to misspell anything. But I'm just gonna call it errors. And then if we do print, and then let's say we print 4 again, then we should get cans. And there you go. We get pairs. And so that is how you update, access, and append. In Python terms, it's called append. In other languages, it probably would be called append, like JavaScript. But in other languages like C++, Java, or C, or I believe or I don't even think C doesn't have vectors. Never mind. But like C++ and Java, they have something called pushback, and it would be the same thing as append, but just that in Python they're more kind of like specific on what they're doing, so like appending and things like that. And so that is list. And so now I'm gonna go over tuples. And tuples, I'm gonna be honest, it's a very similar to list. The only actual difference, if I'm being real honest, is it has parentheses. That's literally all there is to it. And so like there's a thing called unpacking where you're basically I guess you're basically just trying to like add one variable to another, which is the same thing, which is something you'll often see, but the name that they call it is called unpacking, which I find kind of weird in some some cases because like unpacking, like that name made me think. For me, it makes me think of something totally different, but it's called unpacking. But you can add variables together, and it's weird because you have to convert this to a list. And so like tuples are basically a list with parentheses that you can pretty much do. It's basically like the same thing as a list, I guess, just simplifying it. It's basically like a list because if we go back into my same file and we go down here, this is basically what a tuple does in this case. So like for example, in our first tuple, this is how you create a tuple, and this is how you print it out, and this is how you are accessing variables. You notice that it's exactly the same thing as you would with a list up here. And so this, the reason why I say it's for some reason different is because in order to add like in order to like add new items, like or change not add but like change new the updated index, like let's say we want to do pears and change that to apples, we have to weirdly convert it into a list. I think you could probably do it without it being list, but it kind of goes both ways because like because we have to convert it into a list, and then now that it's a list, then we grab its value. We're grabbing Paris because it goes by. I'll write it visually. It goes because to call out each value, you start with one. So you go 0, 1, 2, and 2, 3. So in this case, we only have one. So we're going to do. So this is what that looks like visually, and that's how I'm calling it, as you see here. And so whenever we do this, this is basically the same thing as what we're doing here, but it's just with a tuple, pretty much. And so I'm gonna run it real quick, and so pretty much that's what that does. Is it changes it from pears to apples, and that's pretty much what happens here. I switched the print statements. I thought it was weird, but we're gonna go from here to here. So that's how you update it, and how you add into this tuple is the exact same idea. You have the append function, or you could just do or I think in this or you could just do like remove as well, but it's all pretty much the same. And so now let's move on to dictionaries. Now for you CSI 41 students, this one you guys are gonna learn in C++. It's gonna be called a hash tuple. And so for you guys taking 41, I just want to note, and don't quote me on this, but I just want to note that this is technically what a hash table is. And so in C++, this is the same way. The only difference is there's more specifications in terms of syntax. Python's a really simple language, so this is going to look a lot more simpler. But technically, what a dictionary is basically you have a key and a value, right? And so a key, for example, is brand, and the value is Ford. Now what you are seeing here on the left side is going to be how a dictionary is going to be declared. And so you have the key, and you separate with a colon, the two looking weird ones right here. I honestly thought that's the name. I'm being honest about that. And like, as weird as that sounds, but like it has a key and a value. And so the key is brand, the value is Ford. And so I'm gonna show you guys what it looks like in the same file, because these three kind of all relate to each other, because they're all really similar things in Python, as we're just very different because of the parentheses and brackets. So we have the key and we have the value. And so we go back, like let's say we have fruit, apples, year, and food, and then we have the key. And so the weird thing about this actually is that well, not entirely weird, but it's just different, I would say. That would be a much better wording for it. Is that it's different because you're not calling by index anymore. You're actually specifying the key. So like if I run this, right? Now we're on this part, by the way. I just want to specify that part. We're on this part, and so we have apples. Then we have 1900, spaghetti, and value. We're printing out all the keys, and so oh shoot, I forgot now. Okay, so and then so that's how you pretty much will and that's how you print out the value, right? You pretty much print out the value. And if you do a for loop, right? Like if you do something like I guess like for I in I guess like Python hash table, something like that. Then you could technically, then what you could do is you could do the thing in Python where with hash tables, it's going to be something similar when you guys learn hash tables. It's going to be there are two values called I think in Python it is called key and value. So and they're literally called this, but in C++ for Linux 40, it's going to be called first and second. So I just want to note that. So with this dictionary, you can use that in a for loop, but that just kind of adds more stuff to it. So I want to try to keep this as simple and more digestible. So that's why I didn't really add it into the PowerPoint because that is a whole other thing. So yeah. No, it's exactly like unordered maps. It really is. It's just that you're not doing things like unordered maps and then or like and then you're not having like a hash map or you know. So yeah, it's not like you're doing that. But in Python, you do something like you have curly brackets. That's how you know the hash table, or that's how you know it's another map, or in Python terms, a dictionary. And so you have the key and you have the value. And so how you print out each is what I did was I created a variable called fruit, and I want to grab apples. And how we grab it is we specify the key. And so how we get the key, or no, how we get the value is we just basically type the key. And now I purposely put the comments code here because what if we're printing out the wrong one, right? Like, what if I wanted to get a hash table, but I'm just like, and like, what if I like misspelled it? Well, if we look at it, it's gonna throw an error that says, oh, you can't do this. There's no key value called root. And errors in Python is simple, but it's also a whole new can of worms as well. But with the error messages though, it's much more direct than compared to like C++ sometimes, because if you have memory leak, you sometimes, if like in the linked list assignment, we'll go over like memory leaks and having to figure out like, oh, I'm gonna get a memory leak, and you can delete, you have to think of all of these things. But Python is sometimes it's pretty direct, and sometimes you don't really have to think as much because it tells you. It tells you that, oh, I'm getting a key. Oh, okay, so that means that I'm probably trying to access something using the key that's not even there. And so in Python, it makes it really easy to kind of like do this. And so like I said, I'm not gonna go into error handling because that's also a whole new thing as well. And so I just wanted to show you guys an example of what it looks like when you try access out of range. Basically, a key error is the same thing to out of range, except it tells you that it's a key error, and by then you would already have an idea as a Python programmer what a key and a value is in terms of dictionary. And so this is what a dictionary looks like. It's for the ones this is technically an unordered map, but so just want to point that out. And so this is the hash table. And so now let's move on to object-oriented. Now this is where things get funky. When I first learned object-oriented in Python, I'm not gonna lie, it got me confused half of the time because I had no clue why. Like it felt so different. There was a few things. One, you have if you look on the image on the bottom right here where my mouse is pointing at, the constructor in C++ or in other or in like Java or any other like of the low-level languages, you to have something like, oh, this is your constructor, same name of the class. But in Python, and I'm not sure about JavaScript because I actually don't know JavaScript, is that with constructors, it is called underscore underscore initialize. So init just means initialize. And the weird thing that does get a bit confusing when you first learn Python is like, what is the self keyword does? But self in Python is technically referencing a lot to the class, right? So if you have the same name, and your Python's not gonna know which variable you're referring to. So you have to say, oh, you're referencing to myself. And so they basically, it sounds like they just abbreviated, honestly, and just say myself, took out the my part and just the self, and that's how they thought of member variables. But I always found that odd. And so, but yeah, but that's, this is kind of like a basic initialization of a class. And so what's happening here is I created a constructor. It's called underscore init, like you see here. And I created an object. Of course, it's not you have to do, I did P1 equals person, and I gave it a name and an age, and I printed it out using the dot. Now that dot operator is what's accessing the name variable and the age, the one with the self dot name. That's what it's doing here. And so this is called an object. So we look, like if we go over here, class, there we go. So we go to classes. This is kind of like what that looks like in some cases. So in this demo, I'm gonna show you guys an idea of what classes look like. This is the constructor, and so the constructor is going to take the name and the last name, and we're assigning it to two variables. And so this is kind of like this is what members variables actually are in Python. They have to have Excel keywords. So member variables. This is what the self member variables are. The self is basically saying this is a member variable of the class called person. And so with that in mind, and I'll get to this a bit later, is that it has a member function called print name. And what this does is it's printing out the first and last name like you see here. It's kind of like a void, I guess. Like, I guess to like really like explain this is it doesn't return anything, nor is it also not what you would call it not like specifying like return, but in functions functions here is like a member function whenever it has the self keyword, and so this is all just doing is just print first and last, and so this is basically what a basic class will look like. And if you want to do like more functions, like like here, and let's say you want to do print last name or something, then you could do something like self dot last name, and so that's what that looks like in this case. And so if we do x dot print last name, we have something like probably like this, yeah. That okay. So I forgot to mention, it's not going to work because this is going to it's giving a weird error. But what will normally happen though is that this would print out last name, but I do not know why, because because it's not working, but we'll just discard it for now, because then I'm gonna get into this bit here a little bit, and I'll explain this part more thoroughly, because this is just like a container of classes. So let's say you have a box, right? You have a box, right? Like let's say you have a diagram. Actually, I think a diagram is a good way of going on about this. Diagrams is like having a diagram. It's like you put information in it, and that diagram is like it's like a way of saying, oh, this box is basically representing our company's information, and then this box is what's holding like the name of everyone else who's in the company, last names of everyone else, everyone's work IDs. You know, it's basically what a class is to specify in that part. And so now let's go on to the next part. Oh yeah. Okay. So that's all for the overload. And now let's go over this bit here. So what this is now I thought about going over polymorphism, but I'll only go over half of it because well, I'll go over all of it, but not as in detail because it gets confusing later on in Python. But in Python, polymorphism is just a combination of three things. You have abstraction, encapsulation, and you got polymorphism. So, and why inheritance is part of polymorphism, you say? Well, that is because, good sir, is that a student must inherit from the person. And so what's happening is, I don't know if you guys noticed, but I'm putting Mike and Olson into student because whatever name I do here is going to go into this. That's why this constructor is set up, because this actually in Python, as weird as it may sound, can be called two separate ways. There's like a super dot init. You can do this too, where it does name and last name. You could do something like that, or you could just stick with this one. Let's do that. There we go. So this is kind of like how you have, this is how you're calling the constructor in from the parent class. In this case, this is the parent class, and this is the second class that will basically use information from this class to like take information from us, the user. And so that's kind of like what this is doing. Is it's basically saying, oh, from person, grab the constructor called init, and which is what's happening here. We're doing person access. The dot means access init, initialize. And you're like, okay, the Python compiler goes, grabs the initialize, knows it's there. This is okay. What do you want to do with it? And you put in first name and last name, which is what you do here. And so with that in mind, that's what's happening here. Is it's saying, okay, so you have a student, and from the looks of it, it is grabbing a constructor from the person class and giving it a name and a last name. And so that's basically what that's doing here. And so if we run this, it says Mike Olson here. And so in Python, that is a quick overview of what classes are. Because if we start, and polymorphism is kind of like, basically that actually is what polymorphism is. You have one class that that's like the parent class. And you have another class that has that has subclasses. And so like with that in mind, that's pretty much all polymorphism. That polymorphism is just one parent class being branched out into other subclasses. And so that's just basic polymorphism in a nutshell. And so now let's go on to our next topic, which is operator overloading for this portion. So operator overloading, it's weird, like really weird, because it's actually weird because it's really all just like letters, and so like, well, I guess not weird, but I guess I should stop using weird, but like it's different. but very, I guess, directed, if that's the right word. Probably the right, might not be the right word, but like it's different because you have basically these are called magic methods in Python, and magic methods are just basically anything that has these underscores. So for example, we have an add, operator overloading, basically all the basic arithmetic, right? We have it for like add, subtract, multiplication, division, and power. And somehow, and for some reason, we even have it for right shift and left shifting and a bunch of other things. I won't go over these though, because these are kind of like they kind of go more into 45 topics, and I don't know if I want to go into that. And I think that just kind of complicates things a little bit more. I'll go over more of the easier stuff, the stuff that you guys are doing now. So we're going to go over additions, the four basic arithmetic, add, subtract, multiplication, and a little bit of the equals equals. You can't see it here, but it's under this bit here. And so for this, for this, let me show you what it looks like when we. It's the same exact concept as looking for those of you in for one. And if we go to operators over, let me go over here. Okay, so if we go into then main. Alright. Now, okay, so I created a rectangle class. I guess, like the best way to kind of explain this portion is actually going about like using a rectangle class. And so in this case, this is basically doing this is basically overloading. Well, we're gonna call it changing. This is changing the greater than operator to do doing something else, and that is what that's doing. And so same thing with this is changing. For this one, it is changing the plus operator to do something. This is changing the plus operator to do things with objects. And so objects, like I said, is just basically names that you give to like things to like basically objects are just like a way of accessing information that you give it a name to. And so for example, I gave it a name called rectangle underscore one. This is called an object. And what we're doing is we're using the plus operator to add x and y together. For those of you doing RTX on, I'm pretty sure you guys realize that I'm referencing quite a bit of the RTX on assignment for this a little bit. And so, and for those of you who are not taking 41, all this is doing is it's just adding. It's just an easier, simplified way of adding stuff together. So, like for example, for rectangle one, it goes. We have x and y. This is basically what this is doing for rectangle 1 and 2. And so if we look here, we have x plus x, which is 10 plus 9, and then we got self-y dot rs dot y. It is doing the same thing with this, where it's saying 13 plus 21, it is 34. Yes. And so that's what all it does. And this is what the values of x and y. And so same thing with this is that this is checking to see if these numbers are greater than these group of numbers here. Is 10 greater than 9? Yes. Is 13 greater than 21? Yes. And how you know about that is because it's going to keep saying the right side is true and the other side is false, because the false side is basically comparing to see if these are also bigger than these. And so it's checking to see if they're greater. And so this, and it's going to say true and false, and of course it's going to say true down here, because what that's referring to is this bit over here. And of course it's definitely going to be true, they're basically the same thing over here. So I created two more objects just to kind of like show a different, just to reference off of that. But this is what operator overloading looks like in Python, because you want to manipulate the operators to do something that you might want it to do, like an RTX you have to use like operator overloading to add two rectangles together or see if they intersect and all that stuff. So I'm not going to go into that. I just kind of want to go through the basic foundations of operator overloading. So now let's go through our next topic, which is, I was gonna delete this, but okay, so I'll go over this briefly. But linked list, right? And I'm gonna be honest, I like kind of thought about this for some time, like if I should add this in, but I'm only gonna there's demo code that I did plan on showing, but I'll go over this and then see like if anyone you guys let me know in the comments if you guys want me to go over it, but I'm just gonna go over like what's seen on here. Let me know in the workshop channel if you guys want to go over it. And so for this one, linked list in Python, what's happening is we have a node. So what's happening here is we have a node, right? And a node, all it is like, let's say you have a rectangle, right? You have a rectangle called point here. Like let's say I guess I can't really draw again, but like let's say you have a point to like I don't know like right here. Like let's say this is a point, and then you want to go over here to this point, and it links together. That's what the list is going to do. And then you have another one over here, or we actually go over here. Right. This is actually going to give a really good look at that. So, for example, right, this is all what a node is. It's just a circle that has a lot of data to it that you can do with it. And so with linked list, what you have is you have a set of nodes and they're all linked together like one big line like this. And so if you want to insert, like let's say, for example, those of you who did U4, I'm going to insert 35. If you look at this, look how nice that is, right? That's basically what's in. And it shows you the code too. I sent the link to this page too. If you guys want to mess around with this, I sent this in the 41. And CS1 students, if you guys want to mess around, see what this is, like I sent it in the 41 channel, and if you guys want, you guys can mess around with that as well. I think this is also really interesting to kind of look into, like data structures, because it gives you a better idea of like how things are, kind of just understand logic. And so that's like kind of just want to talk about this briefly because it's a whole other topic on its own, but this is kind of what it looks like visually. And so we want to do like let's say we want to do after tails, we could do like 25, right? And then you do this. It's gonna add another node. And so that's basically all. For those of you who's taking 41, that's basically all what U4 is all about. That's all you're doing is you're just editing the head, and you're doing that's why you have previous pointing. That's why you have head pointing back to previous because you're going back one. You're like going back one, back one, back one for every time you add insert at the beginning, and then the same thing for insert at end is where you're constantly adding end at the end, at the end, and at the end, and setting the next pointer to the new node that is 25. And so this is pretty much what that looks in Python and as well. And so I just wanted to show you guys that so you guys get an idea of what a node looks like, because it can get really confusing understanding this sort of things. And so I just thought bring it out into the light. And so that is technically what linked list is. It's just you have a node, and the list is just basically using objects of nodes like a list, like a bunch of nodes, like two nodes that like decide whether you're going forward or backward. And so that is pretty much how linked list works in Python, and this is pretty much how you do linked list in Python. And if you look at the while loop, it's really simple because most of the time, if you'll notice in Python, most of the stuff is pretty much like pseudocode, right? Where you're just writing out words, and so that's pretty much what's happening here. Is we have while the value in the head node is not null, or in this case called none, we're going to print the data and we're going to keep sending it to the next. So we're going to be I++, right, every time. And so linked list, this is pretty much what that looks like. So you guys get a better vision. The only difference though, if we were to separate this from this to C++, is you're not dealing with memory at all. Because in Python, you don't worry about memory. You just kind of worry about what kind of data you want flowing and how you want to do stuff like that, and do stuff with it. And so this is, but honestly, you don't really need this because if we go back to my list PowerPoint, this is pretty much what it does. Or if we look at another like example, like if you guys remember, I had a tuple, like tuples equals hello, and then like world, right? Like you have that, and then you know how I told you that you said new two equals list? Well, in this case, this is pretty much what I would say is similar to a linked list, because it does basically the things you'd expect a linked list to do. Is it adds and it like goes to the next, and it kind of in Python you might as well just use it. And so that's pretty much what a list is that it's just a function. So that's why so I just want to point that out, saying that that's technically what a list is in Python. And so now let's go back to our original. So yeah, so this is pretty much what's the code here. And yes, I'm pretty sure Karen will notice I am using a single linked list and not a double linked list. I know they're bad, but what can I say? I'm still like, I'm still kind of like regretting a little bit, but like, it's fine though. It's fine, right? It's a single linked list. It makes things easier to learn, and we're not dealing with memory. So, in this case, I think it's fine. But yeah, so I am. So this is what a single linked list. A double linked list is the exact same thing, just more nodes, I guess, if we to put it that way. Single linked list only with one node, doing it all one at a time, and so that's pretty much the end of the top of the list portion. And so, it specifies here you can just call list, which is true. And so, yeah, so that's what linked list looks like in Python. And so now let's go on to the more interesting. Now, this is the part I'm actually excited about to go over with you guys. Now, now I'm going to go over machine learning and artificial intelligence. Now, this is the part that I find fun, interesting, because it's not your typical software development Mojo type of stuff. This is more of like, in order for your program to work, you need reliable data. And so there are three things that so there are three things that you need. But before I go over that, let's see. So the one thing that I want to go over is, let's go over first what is machine learning, right? Machine learning is basically a way for machines, like computers, to learn about the outside world and its data. And so how that works is like, you have a data set, and if I go on here, like if you go here, there are things like 3 data sets, right? And then I guess like if we go to Kaggle, right? There are plenty of that's interesting. But like, if you have like you have these data sets, and these data sets are what's going to help your program actually learn how to do stuff. So it's like you're intellectually giving giving machines data so they can learn, right? It's like they learn from their mistakes. How, like for example, if you feed facial recognitions, no images, it's not gonna learn whose is who. It's going to learn if you give it images to look at, and the more images it looks at, the more it can identify that's that's me, that could be Kearney. It'll be like any one, and so in that case, that's kind of like what machine learning is. You're just giving information into the machine, and the machine is using that information to learn about the information it's given. Like if you give a computer that you built with machine learning concepts, and like it's really good at learning from its data sets that you gave it, for example, and you give it the entire Wikipedia page and scrape the entire thing, like left scrape, I can guarantee it pretty much will know a lot like about like anything that is on Wikipedia. And I think there is a source that the team actually used an artificial intelligence machine learning, built with machine learning, and scraped the entire Wikipedia, and that robot knew how to communicate. It knew a bunch of other things on top of it, that was basically on Wikipedia. And so this is basically what machine learning is that you're just feeding information into a computer and it learns. Like as humans, we learn every day whenever, like for example, we don't know what the color red is until we see it. So it's kind of like that. It's a way for machines to learn about the tasks that they're given, or information like what's the color white. What's the difference between, like for example, a Chihuahua or I don't know, a golden retriever, because they're both dogs, but it can catch it wrong. But machine learning, it knows because it says, okay, a Chihuahua is small, and it compares the traits together of both dogs, despite them being similar because they're both dogs, but it compares based on the traits that they see. Like, oh, it's a Chihuahua, and it doesn't have much fur, golden retriever, throw long hair, it compares that. That is how machine learning works in this case. So it could be numeral, like it says here, data could be represented as numeral traits, or even in categories. And when categories come, it's like different flower types, because you might want to know different types of herbs that are out there, because different herbs help with the development of medicine, and this also speeds up the process. And so that's why I added this portion, is because because like in Kaggle, I'm pretty sure there are like some data sets that's probably going to show like, oh, there's like there's like knowing the difference between like let's say I don't know, I'm not really a herb type of person, but like two different flowers, a sunflower and or like two birds, I guess, like you have a blue jay and then you have like peacock, or I think that's a bird. Yeah, that's a bird. Don't quote me on that. I just want to let everyone know. But so it's just representing comparisons in those data, and so that's what machine learning is. And now that we've gone over that topic, I want to go over linear regression. Linear regression is not as well. It is complicated, but when you go into it, really deep dive into it, not as hard as one thinks. But it kind of is in some ways, because for those who might have taken a little bit of probability, they would have an idea that like linear regression in machine learning, it helps because it helps predict, I guess like it says here, future values, but it's not really predicting that thing. It's more of like deciding on making choices for something, right? Because, for example, if you have a problem, if you think about it, this is kind of like involving more of probability and statistics, right? You're going based off data, so you're gonna go over like, for example, let's say a robot's trying to figure out like out of two dices with 6 sides, if that person's gonna get a 4 or a 2. That would mean that he would have to find like a probability of a 2D 6 and try to find out like combinations of like different varieties of how the dice could be, because it could be 1 4, one dice could be 1 and the other could be 4, the other could be 5 and 6, the other could be like 3 and 1, it could be 2 and 8, but it's going to be really random. And so with that, that's why these things kind of help, because now you're just kind of like understanding. Now some machines are really good at these kind of things because, with humans come with human errors, and so we're not sometimes humans are not great at remembering stuff because there are things we sometimes do forget. But with computers, you could just feed them information, and that information will stick with them pretty much forever until you the programmer, delete the information. And the best thing to do is just go to edit and just do undo, right? Like that might be the best thing. Or if you do Vim, you just type in U and then do stuff. And then you can do that to prevent that data from being deleted. But this is pretty much an idea of linear regression. And I'm not going to go over, I'm only going to go over a little bit over the other stuff that comes from machine learning, because machine learning is really broad, right? Like, there's different variants of machine learning. Machine learning is more of a data science or data analysis kind of thing, because there's constantly dealing with data revolving around inputs and data inputs that are put into a machine, or data that you're coming across every day, like it could be daily, and so it's broad and it's very complicated on its own, because machine learning, it's not just linear regression. Linear regression is not the only thing that you come across. You come across classification, you got data visualization, or now you're trying, like, if you look here, there's data sets for like Greece's earthquake. Now you're, like, it gets really complicated over the matter of that. Like classification, I'm gonna go a brief overview, is that it's just basically just defining which one is which. Like, for example, you have two alcohol, you have two beers, right? It's gonna have to decide and classify which is which. Oh wait, no, that's a Budweiser or that's a Hennessy. It's like that's what machine learning is as well, where you're classifying data and separating them apart from each other. And so in a case like this, that is what machine learning in that sense. And so another way to look at it is, I have a diagram here, and it's more of like, this is actually a good example of classification, because now you have to go really deep into figuring out what makes information different, right? Like, if me and another person grab a red and a green apple, how are they going to tell which apple is green and which apple is red? Well, how you can tell is, you could maybe do some type of classification algorithm, because there are many out there that do classification, like deciding which is which depending on its pattern. It could be based on like colors, and with that kind of gets a little bit tricky, especially since I don't really know much about that portion, about the colors part. But I would recommend it probably be something like dealing with RGB values and stuff like that. And so, like, in this case, we have like in this case, this is also a good example of machine learning, because in machine learning you have these diagrams that point to different values, and so these different values help categorize what it's doing. And so you have experiences, samples, values, and you have nationality, and so forth. And yes, you have arrays of values, but so that's just kind of like I'm gonna be honest. What you're seeing here, for those taking for long, this is an example of binary search tree. Just saying, binary tree actually, not search tree, but binary tree. Just saying. So just wanted to know that part. But this is an idea that you'll see a lot in machine learning diagrams like these. And so that's kind of like the topic with that, with machine learning that I wanted to go over, and we'll go over, like, I guess, like, well, I'll go over socket programming. I forgot to add a slide, but socket programming is like dealing with networking, right? Like for example, like let me just show an example because I actually have one set up. Like for example, like in this case, we're gonna go into this Python. Oh wait, we're gonna do Python workshop, right? And let's say we do chat app. Apologize. So like, so like if we do like chat app bonus, chat app, right? And then let's say you have another one, and let's call this Python. Oh wait, Python, and then let's do Python workshop, right? Chat app, chat, right? And so the reason why you have so with networking in Python, it's tricky because you're dealing with you're dealing with like you're dealing with like different data that are flowing through, and so like for example, like if we do this, right, server, I have a server on, and if we go over here and go into string main.py, I'm gonna put my username. Wait, let me do that real quick. Okay, right? You have a window, but there's also this portion where you can do something like Python stream. Like let's say we put in another password. So username and then oh wait, that doesn't exist. Let me do this. So like it has so let me just do this real quick. Okay. So with socket programming, you have socket programming is having sockets, and these sockets are what's going to do more of the networking side of things, like making connections, listening for connections. You're also dealing with buffering like data, or like using like you're encoding with UTF-8, and all of that with Python is actually really easy. So like with Python, you like for example, like we go and do Python 3 main again, and we do like username and password, you'll notice that it's connected. So we do like hello. You notice how there's two different users messaging each other over the same server. And so like if you do like what's up, bro, and then the other person can see it as well as the other person. And so with this is kind of like not impractical because you wouldn't have a server just set up for a local server, right? Like that'd just be weird in some cases. Like it wouldn't really be like you wouldn't actually really use it. So that's another thing I like to point out. Yes, it's on the local network based, but this is kind of like what socket programming would look when you have a connection. And then when you disconnect, that happens, and then disconnect again, and this happens, and of course a lot of errors. But if we look on the client side, socket programming is like you have a socket, and I forgot what AF and that means, but it means it's all I know is that this means internet, because it's been I was gonna comment out that what these aliases mean, or these naming conventions, and so this is kind of like you have the AFNet, which is like the internet, and then you have the soft stream, which is the streaming. This part just kind of like streams your socket whenever you are like connecting to stuff, and so like so that's pretty much what that's doing here. And then you have like a port, and then this is getting the host by name, because you need to figure out a way to get the IP address, which I definitely won't show here because it's recorded, but you have something like this. And the server is the same way, by the way. sort of the same way. The only difference with the client that I ever made was I created this graphic user interface that you see, and so socket programming is like another way to look at networking in Python, where you have threads and it involves multi-threading, right? And the reason why it involves multi-threading is because you have two processes running at the same time. And so this is where chat applications really need to utilize these multi-threading concepts and networking, because you're constantly having different or you're constantly having these processes, right, that are running at the same time. Like for example, like you saw there, I have a graphic user interface. I have two of them in fact running at the same time, and that's done using multi-threading. And so this is why multi-threading is really important, is because there are times these are good examples of looking at why multi-threading is important, because you are going to need like in game development, you need multi-threading to have multiple players playing the same server. And so that's why you have multi-threading kind of set up in the backend to handle the networking stuff. Like messages, you're dealing with NPCs, players messaging other players is a whole other list of nodes just expanding, like what you see in my background here, you know. And so that's what I wanted to go over is a little bit of programming as well as network socket programming, because socket programming in Python is pretty simple. It's just more wrapping your head around the whole networking conceptual stuff. And so that's what I want to know here. And so that concludes that topic. And now we're getting close to our ending topic. AI. Okay, so with AI, I have a bit of a surprise for those of you who can already know that I'm gonna not just go over machine learning like the theoretical parts, but I'm also gonna show you guys what my a little bit of what I've done over the years in terms of not facial recognition, but artificial intelligence. And so artificial intelligence is it's like it's similar to machine learning. Well, you need machine learning for AI to work the way it wants to expect it, because machine learning here is what's going to help you get the data you want and have the computer do this part, which is doing tasks using human-like intelligence and intellect. And so examples like I've written here is facial recognition, speech recognition, learning speech patterns are one of them. Then, unless you're like me, I built a AI Flappy Bird that just has statistics on the back end and displays that. But I didn't port it onto my desktop, it's on my laptop, and I was gonna show that, but I didn't have enough time, so I will show you guys pretty much what I have. And so so artificial intelligence. This is artificial intelligence is basically that you're having computers trying to do stuff that requires human-like intelligence. Like for example, throwing a ball or a football can be really hard for a machine to do, but you apply artificial intelligence, you can get something as close as if a football player was to throw a football or do stuff like that. And that comes with mechatronics, robotics, as well, because you need the hardware team to help you develop that and co-work together with the software teams to get that working coherently and together. And so artificial intelligence is pretty much that. And like I said, I don't want to go into deep detail because it goes both ways. Machine learning and all of that goes both ways on the hardware and software side. And so with that, I will show you guys my facial recognition project. I will show you guys what it looks like when it detects someone's face well. So just let me hold it up. Okay, so I think I'll finish it. Alright, so here we go. So as you guys see here, hello everyone. I'm going to show. I'm going to show a picture of. I'm going to show a picture about the about what this what you can recognize with this image. And so with this image, for example, like if we look over here, let me lower down the brightness, and so we have something like this, right? Yes. And,
Unknown.
there you go. Yeah, I know, right? I got that working.
Nice,
Look, it knows it's you.
Yeah.
Not Joe Biden, not Obama, because when I was showing people, it kept saying Obama. Don't know why. And so so that's kind of like what that does, right? And so like if we kind of like put it away, right? That's kind of like that's basically what my facial recognition. That's basically an example of facial recognition with Kearney. Yeah, and of course it's not pretty much gonna detect it that well because unless if I can get it right. There. Oh, there you go. Yeah. Yeah, there you go. Yeah, so that is that, and so that is artificial intelligence when you apply facial recognition and honestly how I got that working was I fed data and I fed images into facial recognition to have that completely identify who is who. And so in this case, and currently that facial recognition software that you saw, by the way, I'm actually going to use that for my Raspberry Pi project as well. So that's also one of the things that I haven't planned as well, aside from motion detection. And so with that, that is artificial intelligence in a nutshell. It's just feeding data into it. You're applying machine learning to feed data, use machine learning, group all of that mathematical equations together, make it work, make it detect and do stuff like humans can, and make decisions, and then give that into a machine and make that be the brain, and that brain and that machine learning logic is going to be what helps the machine decide on who is what. How do you look at the facial structure? Because images are not easy. Because you have to do distance, pixelate, and everything, and it's just a whole other set of things. And so that right there is what artificial intelligence is. And sometimes it's not even this easy. Sometimes if you have data sets, you have to clean data, cluster them, filter data, so you have unwanted data, and you have to, depending like if it's flowers, you have to categorize them to see which branch of the family do they go to, which flower, and how do they like branch off of each other, because you have like, for example, you have dogs. Dogs have different breeds, and different breeds have origins of where they come from, and so with that, that's why sometimes it's not as easy, because you're constantly dealing with data that could be data that could have really stuck data that need to be filled in the gap, so that it's easier to detect like, oh, this is a dog, yes, but that's a chihuahua. You know why? And it references all back to the data you gave it, like how humans can, how we can reference the chihuahua because it's small, and if we want to go technical, but sometimes us humans we don't. For the sake of simplicity, we will just say that the chihuahua because look at it, but the machine is going to think of it in a more technical sense, where it's like, oh, it's a chihuahua because it's part of this breed. This breed is part of that breed, and how that breed originated is from this dog. So, and that is, in a nutshell, how artificial intelligence learns about the thing around it, whether it's environment, self-driving cars, driving through driveways and everything. That is pretty much artificial intelligence. And so this is pretty much the last topic, and that is the end of my workshop.
Good
so
job.
Yeah.
All right.
So that's the end of that is the end of my workshop.
Cool. Awesome. I will upload this onto YouTube tonight. And is it okay if people just message you directly with any questions about it?
Yeah. If anyone has any questions about anything I went over, I'll do a disclaimer that if you have any questions about everything I went over or want to know more, I'm actually encouraging. I'm gonna say that right off the bat. I actually encourage people because it's nice to have some curiosity as to what goes on within these advanced topics because they're all real. Because it's really interesting what you go at a deeper level. So
Cool.
yes, I would not mind. Yeah.
All right, I'm going to stop the recording now. Thanks again, Aaron, and appreciate all your time and effort you put into this.
For sure.
Cool.
Always glad.
All right, see ya.